Good morning to all. I am Mr.S.Balasubramanian, working as assistant professor in P.S.R Engineering College. Now I am going to give some basics of embedded systems. So first of all, you know what is meant by embedded system, then only we can see about the embedded system. So system is nothing but a combination or group of elements or components arranged in a particular way to do a particular job. So it may follow some set of rules to do a task. Then embedded means just you are going to give some software that is going to embed in a hardware. So that is called embedded system. Okay. So it's a dedicated computer system designed to work for a single or few, it may be single or few specific functions. It may often contain a larger system. It may build to function with little or no human intervention. So that is the meaning of embedded system. So it's a combination of software and hardware. Just we are going to give some application oriented software that is going to be embedded in a hardware, that is called embedded system. Okay. Then we will see what are the basics of general purpose computers and what are the basic differences between the general purpose computers and embedded computers. So in the general purpose computers, we may have more number of softwares and we may have variety of peripherals maybe connected in a system computers. So at a time, more than one software may be run in a system. Okay. So it may contain the cost of the equipment may be very expensive. So it may possess a distributed architecture, that is the full functionality of the computer is spread across multiple IC chips. So the examples for general purpose computers may be smartphones, tablets, servers, laptops and workstations. So these are the basic examples for general purpose computers. Then the embedded computers. So in embedded computers, that is application oriented software will be embedded. That is only the needed software will be embedded in the hardware. So it may contain some real-time operating system also. So the resources can be embedded on a single IC only. So it may include a variety of peripherals and the size of the system will be very small compared to that general purpose computers. The cost of the embedded computer also is very less compared to general purpose computers. So these are the basic differences in between the general purpose and embedded computers. So in the general purpose computers, we are having more number of hardware resources and software resources. So the performance, that is in the sufficient performance to run many types of software. The general purpose computers may be implemented across many chips. Okay. The cost of the system also very high. Then the embedded computer system is having only application oriented software. So it will be implemented on a single chip only. The software will not that is not going to be changed by user. That is, the user cannot change the software. So the cost of the system also very less or very low. So here you can see the examples for embedded computers. So it may utilize the embedded computers in automotive or some basic office equipments or some aerospace, in home appliances and music players. So these are the basics applications of embedded computers in our life or in our in our society. So these are the basics examples for general purpose computer, that is smartphone, tablet, workstations, laptop and servers. So these are the basics of embedded computers and general purpose computers. I think so I can complete that is basics of embedded system. Then what are the characteristics of embedded system? As we will go to the topic of characteristics. So the first characteristic would be, that is in the application oriented or task specific. So it should contain, so that is in the embedded systems should satisfy, that is task specific. Then time also, that is the time specific also, that is in the, we may have some time limitations, that is where the job should be done within the particular time period, that is the task would be completed within the some particular time period, that is the time specific. Then it should contain minimum user interface, that is it may, that is the user interface would be very less, then only that is it regards to automatic, that is the system should be very much automatic. Then it should provide very high efficiency, that is the output of the system should be very provide very high efficiency. Then the high reliability, that is the output should be constant always in all circumstances or all the time, it should provide the same output, that is highly stable and highly reliability, that is the system should provide highly stable as well as highly reliability. Then the system should provide or it requires only less power, that is it functions only based on the it consumes only less power. Then it should provide that is the system cost should be very less. So these are the basic characteristics of embedded system. So here is the same thing. So all the systems are task specific. So that is they do the same task repeatedly or continuously over their lifetime. So for an example, the MP3 player will function only as an MP3 player, that is task specific. Then the second one, so all the jobs should be done within the particular time period, that is it should have some time period. Okay, so it is follow the time specific, that is time limit. So the work should be done within the particular time period. So for an example, a cause brake system, if exceed the time limit, it may cause some accidents. So that is an example for time specific. Then the third one, so it should contain minimum or less number of user interface, that is no user interface, that is then the efficiency level should be very high, and the size of the system should be very small, and it can be worked with less power, and the system cost should be very less or it should not be too expensive. Then the systems cannot be changed or upgraded by the user. So it should provide high on reliability and high on stability. So in all the systems we can use the microcontroller or microprocessors for doing that is a particular task. The hardware of an embedded system is used for security as well as security and performance. The software is used for the features. So these are the basics characteristics of embedded system. So let us go to the next one, that is what are the different types of embedded system. Here we can split the embedded system into two broad categories. So based on the performance of the microcontroller, that is one category. So the another one is based on the performance and functional requirements, that is the other one category. So based on the performance and functional requirements, we are having four different types. So first one real-time embedded system, the another one standalone embedded system, then third one network embedded system, then the fourth one mobile embedded system. So under the category of based on performance of the microcontroller, we are having three different types, that is small scale, medium scale and sophisticated embedded system. So these are the different types of embedded systems. Then let us see one by one. So based on the performance and functional requirements, we are having four categories, that is real time, standalone, network and mobile. Next one. Real time embedded system. So it's the embedded system will depend on the time, that is the system function depends on the time, that is within the defined specific time, that is a real time embedded system provides the output within a particular specific time. So they are designed and created to perform some specific work in a predefined time. Okay. So there are two types of real-time embedded system. First one, soft real-time embedded system. Another one is hard real-time embedded system. So in the soft real-time system, the meeting of the time deadline is not compulsory for every task. So that is the main point of software real-time embedded system. Here, the meeting of the time deadline is not compulsory for each and every task, but the process would get processed and give the results. Okay, that is a system whose operation degraded if results are not produced according to the specified time requirement. Okay, in the hard real-time embedded system, that is to provide the results within the particular time period. So that is the difference between the soft and hard real-time embedded system. So the example for soft real-time embedded system will be the personal computer, DVD players. So these are the soft real-time embedded systems. Then hard real-time embedded system, the examples for hard real-time embedded system will be flight control system, missile guidance and weapons defense system. So that is in this hard real-time embedded system, the delays in the system are strictly time bound to ensure that all the deadlines would be made at 100% rate, and any missed deadline is considered as a system failure. That is, here you have to meet all the time deadline, but here there is no necessity to meet the time deadline, but it may provide the output, it may process the things and it can give the results. So these are the basic difference in between the soft real-time embedded system and hard real-time embedded systems. So this is the first one under the category of, that is, performance and functional requirements. So the next one, standalone embedded system. So from the name itself you can understand that here there is no change. So always there is no time limit. Okay. Here they are self-sufficient and they doesn't depend on any host system. So whenever an input is received, it will provide the output. So that is the basics of standalone embedded system. So whenever an input is received, then based on the input, there will be some processing takes place. Then it will give some results. So that is the meaning of standalone embedded system. There is no time limit. So whenever you give some input, then it will process the data, then it will give the results. Okay. So the input may be received via sensors or keyboard or push button. So these are the examples for standalone embedded system. First one, temperature measurement systems, some basic appliances like our calculator, or in our home we are using washing machines. So these are all under category of standalone embedded systems. Next one, network embedded system. So from the name itself you can understand that is here the embedded system are interconnected. That is, the things are interconnected together to do a particular job. So it is all the components like sensors, controllers are interconnected. Okay. So the examples for network embedded system will be ATM machines. So this is a best example for network embedded system. So they depend on connected network to perform its assigned tasks. So based on the network, it will do the task. So it depends on the connected network to perform a particular or assigned task. Okay. Then a mobile embedded system. So the mobile embedded systems are, that is nothing but based on that is mobility. So here you can easily move to any place or other place. So they are used in mobile phones and digital cameras because of the small size. They often have memory constraints and lacks good user interface. So the example for mobile embedded system will be the smartphones. So this is the best example for mobile embedded systems. So it can be used in smaller devices. So that is the main purpose of mobile embedded system. So it can be easily transportable from one to other place. So it can be used in any devices, that is the size of the device will be very small. Then next. So in the second category, that is the performance based embedded system. So based on the microcontroller performance, we can classify the embedded system into three types. First one, small scale, then medium scale, then sophisticated embedded systems. So these are the three categories of embedded system based on the microcontroller performance. First one, small scale embedded system. So it's normally the embedded system based on the 8-bit microcontroller only. It's a small scale. Okay. So it will be created or designed using an 8-bit microcontroller. So it may be a battery activated device. So the best example for small scale embedded system will be calculator. Okay. So we can use some basic microcontroller for small scale embedded system. So it will be designed and created based on the 8-bit microcontroller only. So it may be battery activated. Okay. Then the medium scale embedded system. So it will be designed based on the 16-bit or 32-bit microcontroller, or it may be contain more than one number of that is one or two or multiple number of microcontrollers linked together to do a particular application or particular job. So it may have lot number of hardware as well as software complexities. So these are not preferred by many companies. So the best example for medium scale embedded system will be ATM machines, home security systems. These are the two examples for medium scale embedded system. Here you can use 16-bit or 32-bit microcontroller, and so it may have more number of microcontroller system also. It may contain some hardware as well as software complexities. Okay. The next one. The last one, sophisticated embedded system. From the name itself, you understand that here we are going to utilize for our sophisticated life. Okay. So these are designed using multiple number of 32-bit or 64-bit microcontrollers. So these are developed to perform large scale complex functions. These systems having high hardware and software complexity. The example for sophisticated embedded system, GPS system and driverless car. These are the best examples for sophisticated embedded systems. So by using that, we can easy our life by using these embedded systems. Okay. Then what are the challenges in embedded system or embedded software development? So what are the challenges? That is, the first one is the stability. So it should provide stable output for all the time. So that is the main requirement or main challenge. The main challenges in the software development. So it should provide uniform behavior under all circumstances, and it should be able to operate durably without service. So that is the main constraint or main challenge in design of software for embedded system. So it should provide all the time uniform behavior. So that is the main thing. So then next one. Then the second one is safety. So safety is nothing but just that is, the system should not provide any harms to the persons associated with the system. So normally in the application of embedded software associated with life-saving functionality. Okay. So it will be normally associated with life-saving functionality in critical environments, so it should provide some safety to the user as well as the environment. So that is the second constraint or second challenges in the software development. Then third one, security. So security is nothing but just to the embedded system may attack by using some external hardwares or some external may chance for having the software may damage by using some hackers or something because of IoT, that is Internet of Things. Just if the things are connected through internet, then there may be a chance for having hacking of the devices performance. So you should provide the you have to consider security also. So that is the third constraint or third challenge in the embedded system development. Then the next one, then the launch phase. So after developing the particular embedded system, you have to give the product in the particular time, then only we can revenue from the particular device or the particular system. So the time to market and time to revenue is a very important thing. That is when to provide the system or device in the market, and how to earn the money from the embedded system devices, that is developed devices. So this is the next constraint for the embedded software development challenges. Next one. Then design limitations. So the next constraint, that is based on the embedded systems would be very less or very small form factor. So it should consume very less energy, and the performance of the systems would be long term. That is, it should provide all the time. It should provide the output should be same without having any maintenance. So that is the next limitation of design limitations for the embedded system development. So it should provide small form factor. It should consume low energy. Similarly, it should provide stable performance for all the time without having any maintenance. The next one. Then compatibility and integrity. So compatibility is nothing but just we have to, that is the future development should accommodate with the system. That is, the expansion of IoT devices on the background of their connectivity puts more pressure on their adaptability. That is, the user must be capable of administering the app through a simple user interface via all available channels, including over the AirFrame updates, which needs extreme compatibility across the entire ecosystem. That is, all the times the user can compatible with the new developments. That is, the embedded software that is, the embedded system should provide the compatibility also for future updates. Then integrity, that is, you have to protect the IoT from malicious attacks or compromising security must be implemented within each device at every level. That is, it may be in the end node or gateway or cloud, etc. So these are the basics of compatibility and integrity for the software, that is embedded software development. That is the next constraint. So next one, the application of embedded system in all the domains. So it may be mobile communication, or it may be pacemaker or some human intervention devices, then automobiles, then televisions, then transport, RFID, avionics, okay, then telemedicine, then sports. So for all sophisticated system, we can use the embedded system for our life. So whatever may be the whatever may be the inputs or whatever may be your needs, we can apply for our sophisticated life. So these are the main applications of embedded system. Okay, thank you all.